So welcome back to the next video in our Programming with Python series. This is video 5 and we're going to talk about good code. So this is going to take a bit of explaining, but before I start to explain what this is and why we're doing it, I want to say that a lot of this has come out of the exercise sessions yesterday, the IT labs. So it was really good to have these and to see what people were doing, to see people getting used to Python, getting used to the console, the editor, making things work, seeing what happens when things don't work. And so yeah, hopefully you found this useful and have learned a lot from it. I found it interesting seeing how you solve problems and the different ways people did this. And yeah, to emphasize again something I've said before, and I'll probably say again, the way you learn anything is by doing it. So please continue trying to write your own code, trying to make it work, trying to improve it, and just playing with Python. That will make you a better programmer. Okay, so on to good code. So start off, I want to talk about the nice thing about coding. Okay, well, at least one particular nice thing, and that's that you can get immediate feedback. Right, if you're doing some kinds of theoretical problems, you might write your solution and you might wonder if it's correct or you made a mistake, and you might think about it yourself, ask a friend, ask a teacher. But with coding, you can really check things straight away yourself. Right? If you've written some code, you can run it, and the first question is, does it run, or does it complain that there's an error and it won't even run? And then if it does run, you can put in inputs, try things, and check that it does what you thought you did. Right? So this is great. You can really see your thing running straight away and get feedback. Okay, so another thing that's nice about it is that there are different ways to do things. Okay, this is good because it allows us some creativity, it allows us flexibility and freedom. But I have this slightly ominous sentence here: with freedom comes danger. Okay, if you have, it's good to have freedom, but it's also good to know that even though you're free to do some things, they might not be a good idea. And this is something that comes with experience in life and in programming. So I'm going to try and give you some guidance on how to spot some things which are good ways to do things and bad ways to do things. And in the long run, this should make your life easier if you know these things. So this might seem strange at first because, okay, consider this situation where you have two different pieces of code, right, two programs, and they seem to be the same when you run them. To the person sort of playing with them, inputting data to the computer, looking what the computer outputs, they seem to be identical. But I want to ask if one could be better than the other. Right? Behind the scenes, the computer could be doing different things or following different instructions to achieve the same results. And it can be useful to look at how the computer is doing it, even if it seems not to make any difference to the result. Okay, so we're going to talk about what sort of differences might be important and why they might be important. And I'm going to try and really demonstrate this with some examples. So in particular, we're going to think about this burger program that's appeared in previous videos, where you asked whether you want cheese with your burger and you display a price accordingly. And this was in the first IT lab session as well. There was some exercise on trying to extend this burger program. Okay, so let's think about our burger program. So it was a very simple program. So let me remind you how we describe a program pictorially. We use flowcharts. So there were three types of boxes. Okay, start-stop boxes, which were round. There were process boxes, which do things, which are sort of square. They have corners at least. And decision boxes, which are like diamonds. And then there's arrows, which show the flow in our flowchart. Okay, and we can use this to describe the burger program. Okay, this was the flowchart that you saw in a previous video. So there's no input that goes into it. And then it outputs to the screen, do you want some cheese? It takes an input from the keyboard, which is the answer. And then you look at the answer and see if it's yes or no. If it's yes, you output the cost is £5. And if it's no, you output the cost is £4. So let's get some practice. Let's remind ourselves. Let's code this up. So I've got a blank spider set up with a blank file. I'm going to go back and forth between my slides and my spider. So the first thing, okay, there's no input, so that's easy. The first thing is to output, do you want cheese? So I'm just going to follow my flowchart and code this up. output, do you want cheese? I can use print. I want to print a string which says, do you want cheese? Okay, and maybe I could even use a capital letter if I want it to look nice. Okay, so there's the start of my program. And if I'm being good, I should put some comment at the start. Okay, I found my hash symbol on my keyboard. And I'm just going to write basic burger program. For cheese option, maybe this tells me what I'm doing. Okay, so I print do you want cheese. Let's go back to my flowchart and see what's next. I get an input. Okay, I get an input which I'm calling the answer. So I'm going to write answer equals. So I have a new variable. I'm introducing answer, and I'm going to know what to put in it. I'm going to get input from the keyboard. Okay, so now what's next? Then I've got this decision box, and I'm checking whether it's yes or no. And so we saw that the way we do this in practice is I check, is it yes? And then anything else I interpret as no. So I'm going to do my simple version of this. If answer is equal to, which is double equals, the string yes, then I'm going to do something. So I'm going to leave that blank for a minute, option 1. Okay, and if not, this is else. Option 2, and let's remind me what those two options were. So I'm going to go back to my flowchart. If yes, I output the cost is £5. Okay, so let's do that. Print the cost is £5. Okay, and my other option, no, output the cost is £4. Great. Okay, so now I put these placeholders here, option 1 and option 2. I can delete them really. They're not useful now. They were just useful temporarily. Okay, so there's my program. Let's check that it works. So if I need to save this as basic burger .py. I'll just save it there for now. And let's run it. Yep, that's fine. Do I want cheese? Yes, I want cheese. Cost is £5. Do I want cheese? No. Wrong place. No, the cost is £4. Okay, so this does work as we expected. So now I want to think a bit more carefully about this. We know how to draw the flowchart and how to code it up. So there was this exercise. In the IT lab where I asked you to change this by using a variable to store the price. So I want you to think about why I did this, right? And does this make it better or worse? Right. One thing you can argue, which is reasonable, is that this makes it a worse program because it's more complicated. You're now having to introduce variables. The code's probably going to get longer. So maybe you'll say it gets it worse. But this wasn't just this was partly a chance for you to play with variables, but there was more to it than that. In some ways, I think this made the program better, and I'm going to try and explain why. Okay, so another thing to think about is where in the program structure do I display the price? Okay, and does this matter? This will make a bit more sense as I go on, hopefully. So, especially if you think about what would happen if you changed your program, right? This when might such a program be useful, right? In something where you ask about cheese and on a burger and display a price, on its own is not that useful. This is useful as part of something larger, which maybe someone is doing an online takeaway order and they're being asked some questions. I mean, in practice, you might not type in yes and no. You might click on buttons on a phone or an app. But the basic principle of how the computer works and how it takes instructions are the same. Okay, so imagine this as part of something bigger, right? What if you're ordering multiple things and you've maybe ordered pizza before the burgers and you're going to order a kebab after the burgers because there's lots of hungry people you're ordering food for? Okay, so if you think about it in this context, then it starts to make more sense why we would introduce things like variables. Okay, so let's look again at our flowchart for our basic burger program. Here it is. So the beginning bit where we ask, do you want cheese, and get an answer is not too complicated. I think we understand that, and it's and we're not going to try and improve that now. We're just going to concentrate on this decision part. Okay, so I'm going to remove the part of the flowchart that's not important for us now, and just concentrate on this important part, which is how do we make a decision from the answer. And I'm going to move that up in the screen so we've got more space. So what does the exercise ask you to do? It asks you to introduce a variable price and use this to display the cost. Okay, so I'm going to remove some information, which is what we do with the options, and I'm just going to write price on the input arrow to say we're sort of putting some price into this and we want to do something with it. So remember, the question is, do we want cheese or not? And cheese costs £1. So if you do want cheese, it should cost £1 more. If you don't want cheese, the price should stay the same. Okay, the price was £4 for a burger before, but if we've ordered £30 worth of pizza beforehand, the input price might be £34, right? The pizza plus the cost of one burger. So how do we do this? Well, let me put a bit more of my flowchart in. So let's look at no first. If you don't want cheese, it's easy. You just display the price. So I haven't said exactly what words to say, but I've given a basic instruction. We're just going to display the price. Okay, and if you do want cheese, you need to increase the price and then display the price. So here there's a few different ways to do this, right? I've put a little line of code here. This is really code you can have in a Python program. Price equals price plus 1. Remember, this equals is an assignment operator. This changes the value of this variable price to the old value with 1 added. Okay, so it increases the price by 1, which is exactly what we want to do. So something you could do here is you could have these could be different variables, right? I've used the same one. You could have new price equals price plus 1, but I claim it's better just to have a single value of price, because otherwise you've got two different prices floating around, and this is dangerous, right? If you have new price equals price plus 1, then the computer still has a price called price in its memory, which isn't the price. And that makes it easy to make mistakes later. You end up accidentally using the variable price at some point, and it's not the price. So I suggest instead of using a second variable, you just update the one you already had. Okay, and now we have a program where you put in the price, you ask the question, do you want cheese, and you update it accordingly and display the price. So let's do this. So I'm going to change my program. First, I'm going to say we have some price. So in the case of the burger, it was £4. Okay, then we ask, do you want cheese? And depending on the no was easy, right? The cost is, and then we need to display the price. So the way we learn to do this is you can add together two strings. One is the cost is some number of pounds, and then you want to say add the price on, but you need to turn this into a string so the computer knows it's something to display and not something to calculate with. So str means string. Okay, so this should display the cost is and then the price. I wonder if the answer was yes. So let's go back to our flowchart. So first I had price equals price plus 1. I could literally just copy and paste that in. I'm going to type because it's good. It's good to type these things, I think. So price equals price plus 1. And then I can have this same line of code here, right? The cost is, and then display the price. So I'm going to copy and paste that here. Delete, paste. And let's move this so you can see it. Okay, so here's my new program. Let's try and run it. Okay, do I want cheese? Yes. Cost is £5. Let's run it again. Do I want cheese? No. the cost is £4. So this is what I was talking about before, where to the user this looks exactly the same as my old program, but this is but what the computer's doing is different now. Right, so let's save this under a different name. Let's call this variable burger or var burger. Okay. So I claim this is a better program because well, let me show you. Because what if what if we have what if I have spent on pizza is 30, and then I can say the price really is 4 plus what you spent on the pizza, and then I can ask, do you want cheese, and it'll increase it by 1 if you do. Okay, so let's try this. Run. Do I want cheese? Yes, I do. And now it says the cost is £35 because I've spent 30 on cheese, 30 on pizza, 4 on the burger, and 1 on the cheese. Okay, so in the flowchart you can see this. You can play with this price, and the program will still work. Okay, so that helps if there's something going into the program. But what if there's something going out? What if we're using this information? Right, so imagine now we're going to order a kebab. Right, so instead of displaying the price, I then want to ask you questions about your kebab. Right, do you want chili sauce on it? Do you want whatever it might be? So I should change my flowchart, right, and put some stuff about kebabs, which might have some other questions. I haven't worried exactly what my flowchart should be, but I've just put in some bit of a flowchart to show you. But hopefully you can see there's a problem here, right? I should do this whether or not I wanted cheese. So I should also change this right-hand side and have some stuff about kebabs there. But now this is going to get really complicated, right? Well, for every question, I'm going to have branches going out, and I'm going to have to change lots of bits of code. So I haven't done something very well here. Right, so let's think again about this. If I go back to my program where I use a variable to get the price of a burger, how can I make this better where I don't have to update 2 bits of code every time I do something? Well, I can see I've got the same output box twice. So instead of writing it twice, let's change the flow of my program so I only have to write it once. Okay, so I just remove one of them and change the arrows to go back there. So, okay, this is, hopefully you agree this is a nice picture. How do I actually change this into code? Well, it's quite simple, right? You can see it as soon as you look at it, right? There's these 2 bits of code which I copied and pasted, right? So what I'm going to do is I'm going to take this thing and put it down here. So at the end of my if, I'm going to do this bit where I print out the price. And now I can delete it from there and by there. And actually, I don't even need this else now, right? If they say yes, I increase the price. If not, I do nothing. So I can delete this. I mean, you can even delete this line if you want. Okay, so there's my program now, which is better and even simpler and shorter. And let's go back to the situation where there's no pizza. So I'll set that to 0. Let's run it. I'll save it and run it. Do I want cheese? Yes, it's £5. Do I want cheese? No, it's £4. Okay, again, my computer seems to be doing exactly the same thing, whatever I type, but my program has changed, right? And my flowchart is better. Right now, if I want to do stuff about kebabs, I just do stuff about kebabs here, and I only have to do it once. But I can type here, print. Do you want a kebab? And then have some more code. And if I save this and run it, I can say, do I want cheese? Yes. And it will say, do you want a kebab afterwards? And I can say, do you want cheese? No. Do you want cheese? No. It will tell me the price and ask if I want a kebab. It does this whatever happens, right? It goes back to the main structure of my program. So I claim this is a better thing to do. This is a better way to do it. Right? Even if I just want to do the burger situation, this is a better way to do it because there's options to change it later, and it's just simpler. Okay, so let's summarize. We talked about good code and bad code, and the point is that you might start when you're writing a program doing something simple, but very quickly programs get bigger and more complicated. Okay, this is just in real life, if you want to make a computer do something, it gets complicated quick. Okay, and often you need to change your code from what you first wrote. So you want to do things in a good way so that when you come to change it, you make your life as easy as possible. Okay, so good code. Okay, so what is good code? Well, there are at least two things it should have, right? It should be easy to understand when you look at the program, right? If you look at this code I wrote, if you read this, hopefully it's quite easy to understand what the computer is doing. That's the easy to understand and easy to change. I've demonstrated, right? If we want to do something about other foods before or after, we can change it and the code still works. Okay, so what's bad code? Well, it's harder to give one thing and say this is bad code, but we can say some things, some danger points. Right? One is if you're writing the same thing twice, you probably had bad code. Right? So in the original situation where we had two statements, right, where it said the price is £4 and the price is £5, we were getting the computer to display the price is at two different points. So that should be warning bells going off. Oh, this might be a bad way to do it. There might be a better way to do this. Okay, and what's the second warning point? Well, if you just start writing code without thinking about how your program should work, you're more likely to write bad code. Okay, so this is one of the reasons I'm quite keen on these flowcharts. And when you do any serious programming, it's useful to have a pen and paper next to you that you can draw pictures, you can write things to yourself, you can write bullet points, you can think about the structure of your program before you jump in and start coding. Okay, so I hope you found this interesting and helpful, and I hope it's explained to you why I cared about some of these issues with the variables and where we're trying to go with this. We're trying to let you write complicated programs in a good way to make your life as easy as possible. And in future videos, we'll learn about more tools that allow us to do more things, but also allow them to do them in good ways, writing good code.